All right, let's look at this example. We're actually revisiting um, an example with three coin tosses here. So based on the sample space for three coin tosses, oops, and the order of the sample space is 8, one can calculate the theoretical expected probability um, of B, which is the number of heads, using what was learned in the chapter on probability. So here's our sample space outcomes. So this first sample space outcome of getting 3 tails, that means we had 0 heads. And the probability of getting 0 heads, use a highlighter instead. The probability of getting 0 heads would be 1 out of 8, or 0.125. Here is the set of outcomes for 1 head. And the probability of getting 1 head is going to be 3 out of 8, because we had 3 outcomes with exactly 1 head, and that comes out to 0.375. Then we could have 2 heads, and the probability of getting 2 heads, there were 3 out of 8. That's 0.375. And then we could get 3 heads, and the probability of getting 3 heads is 1 out of 8, or 0.125. And if you sum all of these up, then they add up to 1. So the first thing to do is to check and see if this qualifies as a discrete probability function. And first you want to test and see if each of the probabilities for each value in the domain, if they're between 0 and 1, and they all are. Then you want to check and see if all the probabilities add up to 1, and they do. So because these two conditions are met, therefore this random variable is technically a discrete probability function. So let's look at maybe another example of how something like this could be presented. Feel free to pause and try this on your own, and then check your answers with my explanation. So suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days, 15% of the time, and 1 day, 4% of the time, and no days, 1% of the time. Suppose 1 week is randomly selected. So part A is to describe the random variable x in words. So our random variable could use x attendance. Let's change it from x. Let's change it to capital A for attends. She attends class. So that would be the number of days Nancy attends class each week. And so what are the values of our random variable? What's in the domain? What's in the domain of A? So we're going to have lowercase a would be 0 days attended each week, 1 day attended each week, 2 days, 3 days, and 4 days. No, there wasn't a 4. Just 0, 1, 2, and 3. Right? 3 days a week, 2 days a week, 1 day a week, and no days a week. All right. Now, suppose 1 week is randomly chosen. Construct a probability distribution table. So this probability distribution table is going to have 2 columns. One column for our domain values, and the other column for the probability of each one of those domain values. So we have 0, 1, 2, and 3. All right. Now the probability that Nancy attended class 0 days a week was 1% of the time. So that'll be 0.01. The probability that Nancy attended once a week, that was 4% of the time. 2 days a week, that was 15% of the time. And 3 days a week, that was 80% of the time. Now, the next question is, what does the probability of A column sum up to? So we can see here that 0.01 plus 0.04 is 0.05, and 0.15 plus 0.05 is 0.20, and 0.8 plus 0.2 is 1.0. So the sum of all the probabilities of A is equal to 1.0. So, and each of these is a value between 0 and 1. So this would technically be a probability distribution function. Okay. And really, that's it for 4.1. Okay, let me know if you have any questions.